AI enthusiasts. Welcome to the channel AI Champions Hub, where I try to simplify the concepts of AI and share my experience. And we particularly focus on applied AI, AI for business, so to speak. Okay. All right, let's get started. Today's topic is to simplify the definition of AI, and AI really borrows from the biological system that is human beings and so on. So we will look at what are the underpinnings from an AI standpoint in that sense. Okay, so the topic is neural networks explained in a simple manner. All right. Okay, so let's kickstart with AI. You may be somebody who's just getting started or interested but looking for some clarity and so on and so forth. So let's kickstart with the definition of AI, and then we will progress on what are the key elements that AI borrows from a human perspective and how that is represented from a system or a machine standpoint. Okay. All right. So if you look at it, there is no standard definition of AI in that sense, right? So I'm showing you a definition from Britannica where we are talking about essentially an ability for computers or digital systems to be able to perform tasks which are like any other intelligent systems. That's a broad definition. Now, intelligent systems in this case, it could be animals, it could be other things, but we are going to interpret that as human beings for the sake of this particular video. So in simple terms for you, AI is about making sure machines can be taught, trained to bring in capabilities that a human being is able to have, right? Now, for a long time, we know that machines have been very good at large-scale computing, any rule-based systems and so on, and I've done separate video on that topic. I'll share that with you later. But there is a domain where it's been good for computers and other systems to be able to do rule-based applications and so on and so forth. But then for a long period, we humans are good at a lot of cognitive capabilities, right? For us, that is natural. But then it's very difficult to train a computer from a cognitive standpoint up until the AI revolution and the disruption that has been taking off. Up until that point, it has been very difficult in that sense, right? And that is the idea in terms of the entire field of AI, where we are trying to make sure machines can take up the kind of capability that we human beings have, and then they're able to perform tasks that we could do, right, and help us with that in that sense. So, what are these cognitive capabilities, if you may, right? So, if you look at the broader set of cognitive skills, there are multiple that we look at. Perception is one of the key, and perception has visual and auditory, which is what we can see from our eyes, and then what we can hear, which is part of the speech AI domain of work. And then these stimuli or inputs are taken, and then they're brought in from what is called as an attention mechanism, so that you can look at what's important, what's not important. So if there is noise, we don't pay necessarily that attention, but if somebody is speaking, we are interested in that particular conversation and so on. So there could be things like attention parts of it, and then memory is a key part, because we tend to remember things which have happened in the past, things which we have seen, maybe yesterday, last month, several years back, and all of that, right? So short-term, long-term memory is a key part of the entire biological system that's so beautiful, that's human being, right? And then finally, reasoning is a very important capability. We can put together A and B together and say, hey, why I'm going to conclude on certain things or look at a decision. So those are the parts, right? Now, this is the broader spectrum of cognitive capability. So in terms of AI, these are the ones that are being looked at in terms of considering and training and so on and so forth, and simulating and all that. Now, while that's the cognitive capability, the second piece is the core pieces. What we also know is neurons are the fundamental unit that enable this cognitive capability to finally translate into actions, translate into things which are tangible from a human being standpoint, right? So a neuron is central to it in terms of being able to pass the signals, get the perception elements, pass the signals all the way to the brain, and then the brain can send the signals back, and then you are taking actions, right? So that is at a very simplified level, and they are the core of this whole foundational, we can call it as a foundational building block. So therefore, when we talk about a machine being trained, the idea is to take this neuron and then see how that is neuron is structured and how we can use that to mirror the capability that we have so beautifully. So let's deep dive a little bit on the neuron structure. So the neuron has three things in simple terms. So there is an input part of it, which is basically your dendrite, which are sort of your connections which help us get the input from one of these maybe other neurons which are passing out their outputs to this, right? So it's essentially there's a mechanism to collect the input. Then there is a cell body, which is important part where obviously these collected inputs or signals have to be accumulated and then they have to be passed on and processed or whatever you may want to call it, right? So the signal has to traverse and it has to transmit and so on and so forth. So that's a key part from a cell body perspective in that sense. Then the final piece is the output, which is essentially where we talk about taking these signals and then saying, hey, where am I going to pass this output to in terms of the next neuron and so on and so forth. So those are the three sort of your input stimuli that comes in, the signal that can transmit or not transmit and so on and so forth, and then the output where I'm going to say, hey, I'm firing a particular channel or not firing a particular channel, right? Now there is also a concept of accumulating inputs. So there are many inputs that are coming into a particular neuron, and these are all aggregated in a simple sense, and that's what is called the synapse part of it, where there is these inputs are weighed, and necessarily because all the signals are coming in now, I may not, particular neuron may not be necessarily interested in all the signals, right? And it selectively passes certain signals and not pass certain signals, right? So that is the simple part from a biological standpoint: so input, cell body, and output. Now let's take this concept and say, hey, how is it going to work from a human now going into machine and a mathematical standpoint? Now for machines, everything has to be represented in numeric terms, and it has to be represented as a concept or a function or so on and so forth, right? So the equivalent of a neuron is, that is the first concept we look at. So it's basically an artificial neuron. Now an artificial neuron is simulating similar elements. So there is an input, ability to take an input, which could be your data. There are elements which will indicate whether something is going to fire or not, and that's your weights. And these weights are added from a summation standpoint. That's your core of the neural network, and then finally you get the output. Now the aggregation or the deciding factor could be any these functions which take all the weighted inputs, and then they will pass on to the next layer depending on how the summation comes. So it's a weighted sum of things, and there is a bias term and so on and so forth, but don't worry about that level of detail at this point. Just look at the inputs. They are weighted and then they're passed on to a function. Now these functions are obviously there's a summation part to it where I aggregate my input, and then there's a deciding piece which is represented by a function f, and these are called activation functions. So in the biological piece we talked about a certain layer getting firing or not firing, and that activation function helps us do that part. Okay, so now if you look at zoom in a little further, you will see that essentially there's an input section, there's a weighted section, there's an aggregation piece, and then like I said, there is a activation function or a threshold function that will allow us to say, hey, am I going to fire in for a given combination of inputs and so on and so forth, right? Now these weights are important. these functions are critical for us to standardize, and then the threshold functions are also important from that standpoint. Okay, so just remember the four parts: input, weighting in terms of the how the synapse works, and then the aggregation from a cell body perspective, and then the output in terms of axons or whatever we call it. Okay, now let's go to the next concept. So that is, we saw the single unit, which is one neuron. Now obviously our human beings, we have millions of these neurons which are interconnected, and one feeding the other, and so on and so forth. That's how the signal passes through, either through the spinal cord or to the brain or what have you, right? Now, so there are many of these interconnected, and therefore the concept of interconnected neurons needs to be brought in terms of the artificial neural network as well, right? Now we will see that when we finally look at it. So it's not just one neuron that's going to be included. You have many of these connected to each other, and that's what, when we talk about deep learning refers to many of these neurons and the layers of these neurons that are or mathematical neurons that are connected to each other, that are helping with the broader learning and cognitive capability that we talked about earlier. Okay. Now zooming in a little bit on the activation function, you will see that firing or not firing, like I said, is a key part. Activation function are of many types. So the way you have to look at activation function is, it's simple to say, hey, it's like a gate. If a value is of a certain threshold, I'm going to allow it to pass. That means simulating the firing or non-firing of the signal. If the threshold is below a certain value, I'm not going to allow, right? Now, there are various functions, as you can see in the screen, sigmoid or tanh, or these are functions that are available. What you have to remember is, these are thresholds that will fire at a certain point. Like if you take an example of sigmoid, it's essentially, it will going to allow any value from 0 to 1. Anything negative or below that, it's not going to allow, right? And then you see that there are two values here, 0 to 1. So that means if I'm doing a binary classification, I could use this as an element to say, hey, 0 represents somebody not going to churn if I'm a banking major or an insurance major, or 1 could be somebody can churn, right? Or positive sentiment versus negative sentiment, those kind of things. So that is the third concept from an activation standpoint. And then now the fourth concept, if you look at it, it's about how the learning happens, right? So we saw the building block of neuron. We have seen the activation function, the firing and non-firing part of it, and how this is simulated and so on and so forth. Now let's talk about the learning part. Now let's say I'm looking at a function, which is essentially I'm trying to model, given an input, I'm going to do like a 3x or something like that. Now I'm feeding in a lot of data sets as an input. Now the model has to be learning, right? Now I give a lot of examples saying, hey, 3, 4, 5, 600, whatnot. Now what happens is the data is passed on from layer to layer. Now the layers essentially are nothing but, we saw them, they are mathematical functions, and there is the concept of weights that is attached to the unit of work. So let's, so to speak, in simple terms, right? Now in the first pass, I'm going to get some output. So I already have my input, and I know the desired output that I need, right? So I'm passing 3, I'm expecting 9, or in this case, let's say 3x plus y square, some equation, and I'm expecting an output, let's say, of 81. Now in the first pass, you may not get to 81, you may get 72 or 70 or something like that, right? So some starting point weights which are randomly chosen, right? But then the key function from a learning standpoint is calculate the error, which is basically your input minus output in simple terms, or input compared to the output, and then I'll see whether whatever is the difference, and that loss function is a key part of it, where then we decide whether to go and course correct and adjust these weights. Right now, if my output is not closer to the input in an acceptable manner, then I'm going to pass this back, which is called, now I feed this difference or the error factor back into the network, which is called back propagation of error. and basis that the weights are adjusted. Now when it passed back, it's nothing but derivative, which is nothing but rate of change. Now we want to know, am I getting, and this learning is going to be iterative. It's going to iterate over a couple of cycles. So you will need to understand whether am I getting closer to the desired input or desired output, or am I going far off, right? So that is an important thing that you need to look at so that the weights can get adjusted. So there you have it. You finally, through this mechanism of back propagation and computing the loss function, you will be able to quickly adjust these weights. For now, we have taken a very simple example for illustration, but it could be any kind of, it could be an image, it could be voice or speech, and any of these, and these weights are adjusted with the same concept of back propagation and so on and so forth, right? Now, these are the four concepts that are important. So let's put it together. So what happens when we talk about a artificial neural network, which is a core building block of artificial intelligence? Now, essentially, we have seen that neurons are the core unit of work. Now these neurons are layered such that they are interconnected, like the human neurons are. There is activation function which is going to let me know whether something is going to get fired or not, and that's how you see certain things are highlighted, certain things are not highlighted, and for a given input, given combinations, you will see certain things getting fired and certain things not getting fired, right? And the back propagation aspect is ingrained in terms of the iterations that we run, and we go from there. So learning is a key part of it. Okay. So there you have it. You're able to now get a good sense of how the learning happens, what's the building block, and what is the biological inspiration that we are able to draw, right? Which is from our. If you like more such videos, then do subscribe. Do write to me, and we'll be happy to share.